how to square a number. Remember a number squared? 3 squared. Remember that's the same thing as saying 3 times 3. And when they talk about squaring, okay, 3 times 3, that's 9. Because if you think about it, and if you've ever wondered where that, why are some numbers, because when you square a number, there's only certain numbers that could actually be. Okay, because if you think about it, if we've got 9 equally shaped boxes and we put them together, we can actually make a square. Okay, if we were to try that with like 10 or 11, we would have like kind of a random one over here. We wouldn't be able to make a square. So there's only certain numbers that fit that, okay? And those numbers are called perfect squares. You could do that with 4. 4 is a perfect square. 2 times 2 is 4, perfect square. And then 9 would be the next one. That's basically just adding a row and a row. Okay, what would the next one be? Be 16. 4 times 4 is 16. The next one, 5 times 5, 25. Okay, so there's only certain numbers. Those numbers are called perfect squares, okay? They're the only numbers that if you were to, have equal sized boxes, you would actually be able to make a square with those boxes. That's why they're called square numbers, okay? So remember those perfect squares, and you actually probably need to at some point, get those kind of drilled into your head. 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and then probably up to 169. That's 13 squared, and that's probably about as far as you need to go. But those numbers, you kind of want to keep those in the back of your mind because you're going to see those numbers quite a bit, okay? But do we understand 3 squared, that's what that means, okay? You should already know that because I know you had that in a previous lesson. The new concept for this lesson is square root, okay? And this is marked like that. That's the sign for square root, okay? So in this case, the square root of 16. Well, up to now, we've talked about inverse operations. Inverse operations are doing the opposite. The inverse operation of subtraction is addition. The inverse operation of multiplication is division. Well, the square root is the inverse operation of squaring a number, okay? So basically, I've got already my number that's already squared. I want to know, well, what number squared is 16? What number times itself is 16? Well, the square root of 16, 4 times 4 is 16. So the square root of 16 is 4, okay? Now that's where kind of memorizing those perfect squares comes in handy. Because usually you'll see square root of 64, well, what number times itself is 64? Square root of 64 is 8. All right, that's what square root means. Okay, now we're going to talk about, we've got a couple new vocabulary words that come up in this section, rational and irrational numbers, okay? So let's talk about rational numbers. Okay, bottom line with rational numbers, they're pretty much any number that can be written as a fraction, okay? Now, that seems pretty broad. I mean, wouldn't you think that'd be all the numbers? But it's really not, okay? So numbers written as a fraction, so like any whole number can be written as a fraction. Like 3, well, how could I write that as a fraction? 3 over 1, okay? So rational numbers, any whole number. Is a rational number. Okay? Well, any number that can be written as a fraction, well, could any fraction be? No. Any fraction. Okay? That would be like 3/4, 1/3, 2, 6, and so on. Okay? If it can be written as a fraction, it is a rational number. Okay? Now 3/4, now the kind of flip side is, okay, well, so that's also like any decimal, right? Well, not any decimal. This is where it kind of gets a little different, okay? 3/4, 0.75, okay? It is a decimal. This is called a terminating decimal. It has an endpoint, okay? 0.75, that's it. There's nothing else, okay? This is a terminating decimal. That's why 3/4 can be written as a fraction because it can be converted to a decimal, and that decimal ends, okay? Now, 1/3 is a little bit different because this one doesn't end. Okay, if you've ever done 1/3, you know it's 0.33333, and it goes on forever, okay? So this one is a repeating decimal. Basically, it's going to be 0.3 going on forever, okay? But because it was still able to be written as a fraction, it is considered a rational number, okay? And that would be any decimal that repeats, okay? 0.666, you know, it could be 0.232323. As long as it's one that repeats, it's still considered rational, okay? And then 2/6, that's the same thing as 1/3, and so that would be the same thing as that, okay? So the rational numbers, any whole number, any fractions, and then the flip side of that is any decimals that terminate, basically it has an endpoint, or repeat. All right. So examples of rational numbers: 4 is a rational number. 5, 6 is a rational number. 0.895, it ends. It's a rational number. 0.1 repeating forever is a rational number. The square root of 64. Well, the square root of 64, well, we know that's 8. That's a whole number. That's a rational number. Okay? These are all rational numbers. So you're probably wondering, well, what's not a rational number? That seems like that pretty much covers everything, but it really doesn't. There's just a few numbers that don't fit this description. Okay? And this is why we talk about this in the section, because it really involves numbers as squaring numbers. Okay? Irrational numbers. Okay? So the opposite of a rational number is an irrational number. Okay? So irrational numbers, I need to grab my calculator for this to kind of show you. All right, an irrational number is any number that cannot be written as a fraction, okay? So that's kind of hard to picture because if it can't be written as a fraction. Bottom line, what an irrational number is if I try to find the square root of a number that's not a perfect square, okay? Remember those perfect squares are 4, 9, 16, 25, and so on, okay? Say I were to find the square root of 11, okay? We know 11 is not a perfect square. Okay, so on my calculator, I hope you can see this. Okay, yeah, you can see that. Sweet. All right, so I'm going to type in 11, and I'm going to do the square root of that, okay? If I look on this, my answer is 3 point, and then a whole bunch of numbers. And to be honest, and this is not a terminating decimal, okay? Basically, if my screen was bigger and expanded, it would go on forever. Now look at this number. Is there a pattern to it? Does it repeat in any way, shape, or form? No, it's just this random string of numbers after the decimal. Okay, there is no way I could write this as a fraction, okay, because it never ends. It's not anything over anything, okay? So, bottom line, a number that is, if you have to find the square root of a number that's not a perfect square, it's going to be irrational. Any number that is just a string of random number that goes on forever. There is no sign of any pattern or repetition or anything, just a random string of numbers that will go on forever. It is an irrational number. It's impossible to write that as a fraction. Okay, so let's practice identifying rational and irrational numbers. Okay, so let's do a few. Okay, 0.6. Is that rational or irrational? Okay. It's rational. It's a terminating decimal. 0.6, it's a decimal, but it is. It's a terminating decimal. Let's do square root of 15. Well, square root of 15, okay. Well, if you know your perfect squares, you know that's not a perfect square. On my calculator, 15 square root. Oh, look, it's a random string of numbers, okay. There's no repeating, okay. There's no pattern, so this is irrational. So rational, irrational. Okay, 5. Okay, well, it's a whole number. Okay, it's a rational number. Okay, 3/5. Well, 3/5. Well, I mean, this is a giveaway. If I can write it as a fraction, we know it's rational. 0.1717171717. Okay, now. And say we're to continue on and on and on forever. Okay, yes, it does go on and on forever, but is it a repeating decimal? Is there a pattern to it? Yes, it's basically 0.17 repeating. So because it's a repeating decimal, it is a rational number. All right, so good luck with your lesson. I hope that makes sense.